Okay, so welcome to the day three of our computer networks basic to advanced series. And before we jump into today's discussion, let us just go back to what we learned yesterday, or just have a recap of what we learned yesterday. So we started with a bit of a history about why switch was created, what was the purpose of a switch to be created, and how switch basically helps to expand the network in different geographical locations. So we just saw a very hypothetical but pretty much realistic example of how a switch usually helps to grow a particular network physically, right? And then we compared, then we started using an example of a post office, how a post office basically sends a letter from the source to the destination. And then with the address, we learned what is a MAC address, right? Switches use MAC addresses to forward the data, right? So we learned what is a MAC address and how does a MAC address look like. We also saw that on the on a tool which is Wireshark. I think I forgot to tell you, right? So it basically it basically looks like this: B7, B4, AB, 57, 56, 78, like that. A MAC address looks like this, and a MAC address is basically divided into 6 octets, right? And octet meaning it has 8 bits. So whatever number that we see, B7, B4, AB, these are hexadecimal, and if you convert them into their binary format, you will find 8 bits, and that's why it's called as an octet. So you will have 6 octets. That means 6 into 8 bits, right? That gives us 48 bits. So a MAC address for any device is a 48-bit value, right? And then we discussed how a switch basically is forwarding the data from one a PC to the other PC, right? We discussed what is a MAC address table. We compared a MAC address table to the map of a for of a human being. For a human being, the map basically tells how to go to a particular destination and which path should he take to reach that destination. Similarly, a MAC address table on a switch tells the switch how to send the data or forward the data to a particular destination and through which port. So we learned few things, that a particular the MAC address table of a switch is basically empty at the start, right? And then the switch will basically populate the MAC address table when it receives the data, right? And it will populate when it receives the data. It will read the source MAC address and then it will populate the MAC address table. This is what we saw, and we also saw once it receives the data, it will check the destination MAC. If the destination MAC is not present in the MAC address table, the switch will basically forward the data that it received out of all the interfaces. And if the MAC destination MAC is present, right, the switch will forward it out of that respective interface. So we saw this pretty much in a theoretical manner in last class. And in today's class, let's try to understand this practically. Okay. So the tool that you see, what the tool that I have opened is Cisco Packet Tracer. Okay, you can see on the top left corner, it's written as Cisco Packet Tracer, and this is a free tool. Okay, you can go to the Cisco website, or you can just Google. Okay, you can just simply Google Cisco Packet Tracer download. Okay, so you can see this first Cisco Networking Academy's link, right? So once this particular site opens, you need to log in, or first of all, even to log in, you need to create a particular an account. Okay, you can create your account for Cisco Networking Academy, and then you will be able to download the packet tracer. Okay, so as I said, it's a free tool. It's not paid. You can download it and you can run it anywhere. You can run it in your local PC. You can also run it in your office laptop as well. So it's free to use. Now, this tool basically helps us visualize how networking devices communicate with each other, and how they are, what kind of data they are sending, or what kind of information they are able to communicate with each other. This is what this Cisco Packet Tracer tool works like. So basically, in other words, it's a simulator. Okay. So it's a simulator. It's a real time simulator. It's not exactly, obviously, it's a tool. It's everything is virtual. So, and that is why it is called as a simulator. Right? So Cisco Packet Tracer is a simulator, and there are other simulators as well. Okay, there are other simulators as well. Cisco Packet Tracer is dedicated only for Cisco devices. Okay, it is only for Cisco devices. Then there are other simulators as well, which I will also show you. The other simulator that I majorly use, or like 99% of the time which I use, is GNS3. This this is a freeware. Okay, but this is an open source tool. Okay, this is an open source software. Again, GNS3 is a very common name. You can search on Google, and you can say just like download GNS3. You can download GNS3 as well. Okay, but when I am using GNS3, I will show you how to from where you need to download GNS3, how to install GNS3, etc. It's a bit tricky to start working with GNS3. Okay, so we'll discuss GNS3 later, but for now, let's concentrate on how switch works on this particular tool, which is your Cisco Packet Tracer. Okay. Now on this Packet Tracer, okay, at the bottom left corner, you can see different symbols. Okay, you can see different symbols over here, and these different symbols are nothing but different networking devices. All right. So I'm not going to go in much detail of how to use the tool. Okay, I would leave that to you once you download the software, and once you get a once you get a hands on how to navigate across the basic navigation of this tool. I'm leaving it to you to explore these different devices. Okay, so over here, what I will do is I will click on the networking device, and I will click on a switch, and I will drag and drop it over here. Okay, and I will connect different PCs. Just like we have four different PCs in our theory. So I'll connect four different PCs: PC number one, PC two, PC three, and PC number four. Okay, and I will connect it using a cable. So there are different cables. You have a console cable. Okay, I'll talk about these different types of cables. Okay, yeah. So if you can see here, you can see a copper straight through cable, a crossover cable. So if you have gone through the recording of day one where I was talking about cables, you would now know what is a crossover cable and what is a straight through cable, right? So there are different types of cables. You can see fiber cable, phone cable, etc., coaxial cable. There are different types of cables. What I will do, I will just click on this one, the symbol of a lightning bolt. Why? It will automatically choose the cable by itself. Okay, I don't have to worry about what cable is it using. So I will connect PC to these switches. Sorry, different PCs to this switch. Okay, connecting is very easy. Just click on this PC and click on switch number one. Again, click on PC number four, drag and drop it at switch number one. Okay, so these are four different PCs. Before I move, is the diagram clear? Can you see the fonts of the diagram? Okay, now what I will do, I will assign some IP addresses. Okay, don't worry if you do not know what an IP address is, because we'll talk about IP addresses probably in our later sessions. But for now, just go with the flow, what I'm trying to teach. Okay, so our purpose for today's class is to understand how the switch is working. Okay, don't concentrate on if you these IP addresses, whatever I'm assigning. Okay, we'll talk about IP addresses, what is the significance of IP addresses in later classes. Okay, so now I have assigned IP addresses to these different PCs. And let me just quickly do some kind of pre-work. 10.0.0.2, 3, 4. PC 2. I will explain these things probably a bit later, but don't worry as of now. Okay. 3. Now, so we are going to discuss what we learned yesterday in the theory session, where we were discussing how a switch is able to communicate or send data from one PC to another PC. Okay, this is what we learned yesterday, and we are going to look at that particular scenario in practical over here. Okay, so now what I'm going to do, I will try to ping. I will try to ping from PC number 1 to PC number 3. Now, anyone who is new, okay, ping, okay, ping is basically like a connectivity command. Okay, it's like a connectivity check command. Okay, so whenever you're trying to check a connectivity between one PC to the other PC, what you basically do is you will type ping and the IP address of this particular PC, PC number 3. Okay, and what this PC number 1 will do, it will send a message to PC number 3 expecting a response back. That is basically a ping. Okay, I know most of us know, but there are still people who are watching the recording. There are people who do not know what a ping is. So for them, I am explaining what a ping is about. And we will use this ping word a lot in our future classes or even in our discussion today. So over here, what I'm going to do from PC number 1, I will ping PC number 3. Ping PC number 3's IP address was 10.0.0.3. Okay. Now, here, the moment I did a ping, you can see this PC has created a packet. Okay, it looks like an envelope, right? It looks like a letter or an envelope, right? It looks like that. So let us first of all open and see what is the information present. All right. Now we will see. We will be concentrating only on the layer 2. Layer 2, which from the OSI layer model, we will be concentrating on layer 2, and you can see this particular information. We'll talk about these information in detail probably in later classes. But for now, let's just concentrate on the fields where destination MAC address and source MAC address is written. Let's just concentrate on that part. And let's just concentrate on the last 4 digits of these MAC addresses so that it's easier for us to remember. Okay, so you can see here, I am trying to ping. Okay, I am trying to ping from PC number 1 to PC number 3. Okay, now you can see here, when I do a ping, so obviously PC1 will have a source MAC address, right? And the destination MAC address will be for PC number 3. Correct. So the source MAC address, PC1, this is the source MAC address of the PC number 1. It is trying to send a data to PC number 3. This is PC number 3's MAC address. All right. Now, PC number 1 sends this data to the switch. The switch will receive it. And if you remember, okay, before that, let me show you the do not worry about whatever you're seeing here. Okay, let me first explain how the switch is forwarding their data, and then we'll discuss how to log in into a switch, right? How to see each and every different commands in late. I'll explain that that part a bit later. For now, we are concentrating only on the part how switch is forwarding the data, right? So over here, if I want to check the MAC address table of the switch, we saw what a MAC address table will basically look like in yesterday's class. So to see the MAC address of a switch, you need to write the command show MAC address table. Okay, show MAC address table. And let me clear this again. Okay, so over here, you can see it says a MAC address and port. This is what we have been looking at in yesterday's class, a MAC address and a port. These two are very important columns of a MAC address table for a switch, right? So we can clearly see these two columns, and for our discussion today, we are going to concentrate only on these two columns. There are other columns as well. We're not going to discuss that. We'll be discussing only these two columns, right? Now, the PC forwards this data or sends this data to switch, right? And we discussed yesterday, when the switch or the switch populates the data, when it populates the MAC address table when it receives a data. So here it has received a data. It has received a data from PC number 1, and it will populate the MAC address table using the source MAC inside the data, right? So let's check what is the source MAC address. The source MAC address ends with 4664, right, which is PC number 1's MAC address. And let's open the MAC address table of switch number 1. So show MAC address table. Uh, okay, let's go back to this table before I clear it. So you can see here 4664. Okay, 4664 is the MAC address of PC number 1, and the table, let me scroll up. You can see this table was completely empty. Earlier it was empty, but when it received the data, right? When it received the data, it read the source MAC address on the data, and the source MAC address was 4664, and it made a note of the interface that it received on. Okay, fast Ethernet 0/1. Now, what does this fast Ethernet 0/1 looks like, or what does it mean? So if you remember, we when we were discussing about the different ports, sorry, not different cables, there was an Ethernet cable, then there was a fast Ethernet cable, then there was a gigabit Ethernet cable, 10 gig cable, etc. Similarly, you have different interfaces or ports on a particular switch. Depending on the speed of that port, different ports are categorized on that. So over here, this switch, okay, this switch is connected to PC number 1 on a fast Ethernet. FA means fast Ethernet, meaning that the speed is I think 100 Mbps. Give me a minute. Let me go back to the cabling part and check. Mhm. Okay, yeah, 100 Mbps. So the speed of that port is 100 Mbps, right? Over here, all these ports, if you can see fast Ethernet, fast Ethernet, fast Ethernet, fast Ethernet, the speed of these interfaces or ports of that particular switch is 100 Mbps. Okay, so now on this switch's MAC address table, you can see the data was received on fast Ethernet 0/1 from a source, or from a source which has a MAC address of 4664. So it made a note of it. right? Then the second thing that it checks is for the destination MAC address. Does it know the destination MAC address? Okay, we know that the destination MAC address for this particular data is 433D, 433D, right? And is 433D present in the MAC address table of this switch? It is not present. You can see the 433D MAC address is not present in the MAC address table. And if the MAC address table does not have the destination MAC, if the destination MAC is not present in the table, what the switch is going to do? The switch will forward it out of all the interfaces, right? And let's check that. So over here, 433D is not present in the switch. So here, see here, you can clearly see the switch is forwarding the data out of all the interfaces except for the interface that it received the data from. So it will forward it to PC number 2, it will forward to PC number 3, it will also forward to PC number 4, but it will not forward back to PC number 1. Okay. So PC number 2 rejects this data, PC number 4 rejects this data because the MAC address, the destination MAC address is not of PC number 2 and is not of PC number 4 as well. It is for PC number 3, and you can clearly see here that PC number 3 has not marked it as cross. It has accepted the data, correct? Now, PC number 3 is going to respond, correct? When PC number 3 responds, this is the inbound, meaning this you can see here, inbound and outbound detail. Inbound means the data that is received. This data was received by PC number 3. So when it received the data, it saw the destination MAC 433D, which is PC number 3's MAC address only. So PC number 3 accepted it. Right. Now PC number 3 is responding. When PC number 3 responds, the outgoing packet, you can see the source MAC address now becomes PC number 3's MAC address, and destination MAC becomes PC number 1's MAC address. The addresses are changed, right? Now PC number 3 sends the response to switch number 1. Now, when switch number 1 receives it, let's check. As we know, when the switch receives the data, it will populate the MAC address using the source MAC address. So let's do a show MAC address table, and we can see 433D has been populated with the interface number of fast Ethernet 0/3 over here. And because previously I cleared the MAC address, right? The MAC address of PC number 1 is not present in the MAC address table. Please remember, generally what would have happened is, in a normal scenario, what would have happened is, we will see PC number 1's MAC address as well. PC 1's MAC address as well here with fast Ethernet 0/1 mentioned like this. Okay. However, because I cleared the MAC address table, okay, I cleared the MAC address table. That is why PC 1's MAC address is not present. PC 1's MAC address is not present. And because PC 1's MAC address again is not present, what the switch is going to do? Can someone tell me? Can you guys hear me? Hello?
Yes, sir. Broadcast.
Yes, it will broadcast. Right. So because PC 1's MAC address is not present in the MAC address table, it will again forward it to all the different devices. As I said, this is not an ideal scenario. It should not have happened. It happened because once the data was received, when the data was received by switch number 1, I cleared the MAC address table once again. I cleared the MAC address table. Right. That is why switch number 1 did not register PC 1's MAC address. And because of that, when PC number 3 was responding, switch 1 was unaware of PC 1's MAC address, right? So in an ideal scenario, what would have happened when PC number 1 sends the data? switch 1 will keep the entry for PC number 1 on fast Ethernet 0/1, and when PC number 3 responds, it will make an entry for PC number 3 on fast Ethernet 0/3, and instead of broadcasting it out of all the interfaces, it would not broadcast it, it will directly send it to PC number 1 because it knows about the MAC address of PC number 1. All right. But in this scenario, because I deleted the MAC address table, cleared the MAC address table of switch number 1, switch did not know about the MAC address of PC number 1, and hence it had to broadcast it. Anyway, PC1 has now received it. Okay. Now, PC1, if we check the MAC address table of, switch, we can see PC number 3's MAC address, and we can also see PC number 1's MAC address. So next time, if PC1 and PC3, they communicate, there will be no broadcast. There will be no broadcast. No broadcast meaning PC number 2 and PC number 4 will not receive the data. It will be only received between PC1 and PC3. So let's check that. Let me do the ping again. So now you can see PC number 1 forwards data to switch. Switch will only forward that data to PC number 2. Now, because the destination MAC, that is PC number 3's MAC address, that's wrong. PC3's MAC address is present in the MAC address table of the switch, and that is why it is able to forward the data. Similarly, when PC number 3 responds, PC1's MAC address is present. The destination MAC now is PC1's MAC address, which is present in the MAC address table of the switch. The switch will directly forward it to PC number 1 only. Okay, so this is what we saw yesterday in the class. Now again, if I want to show you the scenario with PC number 2 and PC number 4, let's do that. So let's try to ping PC2 and PC4. Okay, so for PC number 2, let's ping 10.0.0.4. Okay, when I do that, we can see a packet is created. Okay, a packet is created, and again, we'll concentrate only on the layer 2 or the Ethernet layer, and also only on the destination and the source MAC. Source MAC is A3EC, which is PC number 2's MAC address, and 444DC is PC number 4's MAC address. Okay, let's see what happens. PC forwards it to switch, right? Switch will receive it. It will make an entry of the source MAC address. Show MAC address table, and we can see A3EC, which is PC2's MAC address, has made an entry in the MAC address table. But the destination MAC of PC number 4, what is the destination MAC? Destination MAC is 44DC. Is 44DC present in the MAC address table? No, we cannot see 44DC in the MAC address table, and hence this packet will be broadcasted. It will be another word for forwarding out of all the interface is broadcast. It will broadcast it to all the interfaces. PC number 1 and PC number 3 will reject it because that destination MAC is not their MAC. PC4 will receive it, and PC4 will respond, right? When PC4 will respond, the details will be changed. Destination is now PC2's MAC address. Source is now PC4's own MAC address. Okay. Now PC4 responds. Switch will receive it. And then what will switch do? Switch will make an entry using the source MAC address. So we can see 44DC, which is PC number 4's MAC address, is now is now an it has an entry in the MAC address table with fast Ethernet 0/4 as the port. Then the destination MAC is A3EC, right? It checks, does it know how to forward a data towards A3EC MAC address? Yes. And to forward the data, it needs to forward the data out of 0/2. And hence, instead of broadcasting it out of all the interfaces, it will forward the data only out of 0/2. And it will be received by PC number 2. Okay. So this is how a switch learns the MAC address, populates the MAC address, and forwards the data using the MAC address table. Okay. Any question? Anyone?
So can we clear any single MAC address, or it will be clear the full table only anytime we want to clear that?
Let me check if we can clear. Now you can clear, or you can only clear the whole
The full table, right? Full table is
full
enough.
table. Yes,
Okay, okay.
not a single. Yeah. Okay. Naresh, Deepak, any question you guys have? Is this clear? The working of a switch, of how it forwards the data.
No, sir, it's clear. But
Hmm.
switch already knows the MAC address of PC1 and PC3, right? While sending to PC4. Still, why it is broadcasting?
Okay. It is broadcasting because it does not know the MAC address of PC number 2. Okay. Your question is valid. It knows that on this interface and on this interface, PC3 and PC1 are present. Your question is, why is it forwarding to these guys? Correct. This is what your question is. Right. It is forwarding it because it only knows that the PC, this PC is connected over here. It does not know after how many devices is this PC connected.
Okay.
Okay. It can be connected like this over here and then a PC over here.
Okay,
Okay.
sir. Okay.
Or like, instead of PC number 3 over here, there is a switch and then a PC number 3 over here, and then there is a PC number 4 over here, or any other PC. So on this switch interface, two MAC addresses will be present. Okay, this PC's MAC address will be present, and PC number 3's MAC address will be present, and the port number will be mentioned as 0/3. Okay,
Okay.
so here what is happening is, though it knows that on this two interfaces, a particular MAC address is present. However, this guy, is he sitting behind this guy? He does not know. He does not know this PC, right? Is it directly connected? Is it indirectly connected? It is completely unaware of that situation. It only knows that he, I received a data. I received a data from some guy. Okay, on this interface. So if I want to forward the data to this MAC address, I need to send the data out of it. Now, to reach this guy, how many switches is it crossing? How many PCs is it crossing? How many routers is it crossing? Is it crossing the whole internet to reach that? I am not aware of. I only know that to reach to PC number 3, I need to forward the data out of this internet. That's all.
Okay, sir. Understand.
So on a single interface, you can receive multiple MAC addresses.
Okay.
Got my point? I'll
Yes, sir.
explain this. Okay, you got a good point. Let me explain that with a scenario of two switches. With a scenario of two switches. Okay. But Deepak, any question with this one? before I start the next part. Okay, so with one single switch, we are okay how it is working. Let's expand that scenario. Switch number 1 and switch number 2. Okay, let's connect PCs. PC 1, PC 2, PC 3. Okay, PC number 1, 2, 3, 4, 5, and 6. And just for simplicity and understanding sake, again, the MAC addresses of these PCs are their respective numbers 1111, 2222, 3333, meaning that all the digits of the MAC address is that number. So for PC number 2, the MAC address will be 2222. This is 3333. For PC number 4, it is 4444, 5555, 6666. Okay. Now let me mark the interface numbers as well. 1, 2, 3, 4. This is 5, 6, 7, and 8. These are the interface numbers. Okay. Now the real interface numbers we just saw on the Cisco packet tracer, it is given as fastnet 0/1, 2, 3, 4, etc. But this is only for the understanding purpose that I have numbered them as 1, 2, 3, 4. Okay. Now let's see when PC number 1 is sending a data to PC number 6, which is over here. What is going to happen? Source MAC will be 1111. Destination MAC is going to be 6666. Correct. Now this data is sent. Let me use a different color. Let me use a black. This data is sent. Now for switch number 1, let's make the MAC address table. MAC and port. So it sees that I have received a data where the source MAC address is 1111, 1111, and on the interface number 1. Okay. Then do I know the destination MAC 6666? No, I do not know the destination. So I will forward it out of all the other interfaces. So it forwards it out of all the interfaces. PC number 2 and PC number 3 will reject this data. Now, this data is sent to switch number 2. Now, for switch number 2's, it also has a MAC address table. Right? So it will see that I have received a data again with a MAC address where the source MAC address is 1111, and I received it on my interface number 5. Right? Then it checks the destination MAC 6666. Is it present in my MAC address table? No, it is not present in my MAC address table. So I will forward it out of all the interfaces. So switch number 4 and 5 will reject it because that's not their MAC address. PC number 6 will accept it. Okay. Is this flow clear?
Yes, sir.
Yeah. Right. Now.
Right.
Now, PC6 will respond. When PC6 will respond, source MAC. Source MAC is going to be 6666. Destination MAC is going to be 1111. Okay. Now, switch 2 will receive it. Switch 2 will see, I have received a data with a source MAC. Is this source MAC present in my MAC address table? No, it is not present. So let me make a note of it. 6666. I received it on interface number 8. Then it checks the destination MAC. Do I know the destination MAC? Yes, I know the destination MAC. And how should I forward it? I should forward it out of interface number 5. So here, instead of forwarding or broadcasting it, it will forward it out of only interface number 5. It will forward it out of interface number 5 only. Okay, then switch number 1 will receive it. Switch number one will see, I have received a data where the source MAC is 6666. So let me make an entry of it. And I received it on interface number 4. Okay, I received it on interface number 4. Now, do I know the destination MAC 1111? Yes, I know how to forward it out of interface number 1. So PC number 1 receives the data. Okay, is this flow clear?
Yes, sir.
Yes.
Now, let's check for something else. Let's say for PC number 2 and PC number 4. PC number 2 and PC number 4. Source MAC is going to be 2222. Destination MAC is going to be 4444. Right. PC number 2 sends the data. Switch 1 receives it. Switch 1 will see, I have received a data with a source MAC of 2222. And I received it on my interface number 2. Okay. Then destination MAC. Do I know the destination MAC? No, I do not know. But if I do not know, what I will do, I will forward it. Will forward it to PC number 1, not PC number 1. I will forward it out of all the interfaces. Okay. It is forwarding only out of those interfaces. It does not know after the data is sent out of this interface, where is it going? Is it going directly to a PC? Is it directly going to a switch? It does not know. It only forwards the data out of that interface. That's all. Okay. And this is a very good example. To reach any of these PCs, PC number 4, PC number 5, PC number 6, the data that switch number 1 needs to forward is out of interface number 4. Correct?
Yes. Correct.
Yes. That is why, even though in our earlier scenario, in this practical over here, even though switch number 1 knew that PC number 3 and PC number 1 are connected on these two interfaces, it will still forward it. Because as I said, it only knows that this MAC address was received on these two interfaces. Are those devices directly connected to me, or indirectly connected to me, or are they in the other side of the globe? I do not know. All I know is that I need to forward it out of that interface, because this is a clear example. Okay, once this whole scenario is complete, you will understand. So over here, switch number 1 does not know the MAC address of switch PC number 4, so it forwards the data. Switch 2 receives it. Switch 2 will make a note of it. 4444 was received on interface number 5. See here, two different MAC addresses are received on the same interface.
Yes.
Right. Then it checks the sorry, not 4444, 222. 2222 received on same interface. So 2222, does it know the destination MAC? No. So it will forward it out of all the interfaces. It forwards it. PC number 5 and 6 will reject it. PC number 4 will receive it. Okay. PC number 4 receives it. And when PC number 4 receives it, it will respond. When it responds, source MAC is going to be 4444. Destination MAC is going to be 2222. Correct?
Yes.
Forwards it. Switch 2 will receive it. Switch 2 will make an entry because 4444 is not present in the MAC address table. And it was received on interface number 6. Then it checks the destination. Do I know how to reach the destination MAC? Yes. That is again out of interface number 5. So to reach multiple MAC addresses, same interface may be used. Now you got the point why switch had to, even though it knew that a particular MAC address is present on that particular port, and it doesn't, even if it does not know the destination MAC address, it has to forward out of that interface. Because you can clearly see here, two different MAC addresses. To reach two different MAC addresses, one single port is being used. That is why a broadcast never checks if a MAC address is already present on that interface or not. I will broadcast. Clear? Naresh, I
Yes.
hope your answer is clear with this explanation.
Yes, yes, sir. It's clear.
Right.
Yeah.
Now,
Thank you.
to reach 2222, it needs to forward out of 5. So it will only forward it out of 5. It will not broadcast it because the destination MAC is present in the MAC table. Switch number 1 receives it. It makes an entry that to reach a source MAC of 4444, I have received it on interface number 4. Again, two different MAC addresses, same port. Okay, then it checks the destination MAC 2222. To reach 2222, it needs to forward the data out of interface number. So it will forward the data here. Clear with how now you can increase you can increase the whole you can increase the topology. You can add multiple switches. The working remains the same of how data is forwarded. All right. Any question? Anyone? Okay. Now with this, we learned few things, and that is types of traffic in a layer 2 only environment or layer 2 network. When I say layer 2 network, I mean which involves only MAC addresses. Types of traffic in a layer 2 only network or in a MAC address only network, where the switches or where the devices understand only MAC. Now, what are those type of traffic? First is a unicast. We all know this word. What is a unicast? Meaning one-to-one communication. Okay, that means there is a source MAC address and there is a destination MAC address. And this destination MAC address is present in the MAC address table of the switch. Right? The source MAC address, yes. Okay, if the source MAC address is not present in the MAC address table, it's not a problem for this switch. Why? Because using the source MAC address, the MAC address table is populated. Right? So if the source MAC address is not present, it's okay because the switch will make an entry. Right? Now, for a unicast, the destination MAC should be present in the MAC address table. So in this case, for example, 6666 was present in the MAC address table using interface number 4 or whatever the interface was. So over here, when the data is received, source MAC is present and the destination MAC is in the MAC address table. That is what you call it as unicast, one-to-one communication. Okay, one-to-one communication. Second is a broadcast. Broadcast. Broadcast is one to all. One source MAC and all destination addresses. Okay, when we are talking all destination addresses, the MAC address, okay, the MAC address will have all the digits as FFFF, meaning the 6 octets. We were talking about these 6 octets. The octets will have all the digits as FFFFFFF like that. That is a broadcast MAC address. And this broadcast MAC address need not be present in the MAC address table because it is a feature or it is a feature that is known by every networking device that if a destination MAC is FFFF, if I receive a data and in that data, the destination MAC is FFFF, I need to forward the data out of all the interfaces. That is a broadcast. Okay. So this this MAC address, broadcast MAC address, FFFF, need not be present in the MAC address table. It is a default understanding of this switch that if a broadcast MAC address is received, I will forward it out of all the interfaces. Okay. The third type of traffic is unknown unicast. Unknown unicast. Okay. Now, what is unknown unicast? Unknown unicast means, let's understand what is a unicast. We already know what is a unicast, where there is a source MAC address and there is also destination MAC address. And why is it unknown? Because in the MAC address table, this destination MAC is not present. The destination MAC is not present. So all our scenarios over here, where when the PC, when PC1 or PC number 2 was sending a data to PC number 4, switch did not know the MAC address of 4444. There was a source MAC, there is a destination MAC. However, this destination MAC was not present in the MAC address table of switch. And when the destination MAC is not present in the MAC address table of the switch, what is the switch going to do? Switch is again going to broadcast it. It will broadcast. Here, when I'm saying broadcast it, it means send out from all interfaces. All interface. That's what broadcast. Here, broadcast does not mean this broadcast, where the MAC address is FFF. This term broadcast means to flood, or instead of this, let me use another term, flood. Flooding. It will flood the data out of all the interfaces. So basically, if you see, this unknown unicast acts very similar to a broadcast. However, it is unicast because there is a source MAC address present, there's a destination MAC present in the data. But it is unknown because the destination MAC is unknown to the switch. It's not present in the MAC address table. That is why it's called as an unknown unicast. All right, any question understanding these three types of traffic?
Okay, can you explain the unknown unicast once?
Yeah. So let me explain it with the simple diagram. Switch 1, multiple PCs. Okay, PC1, PC2, PC3, PC4. Okay, 1111 is the 3333 is the MAC address over here. Interface number 1, 2, 3, and 4. So when PC number 1 with a source MAC of 1111 sends a data to PC number 3 with a MAC address of 3333, what happens? For a switch, in the MAC address table, let's consider the MAC address table to be empty. Okay. Here, PC forwards the data. It is received by the switch. Switch, as I said, will first read the source MAC address in order to populate the MAC address table. And it will make an entry 1111 with a entry, a port number of 1. Then, please remember, this is a unicast. This is a unicast where it's a one-to-one communication, correct? But for the switch, though the data is a unicast, the destination MAC address is not present in the MAC address table, or you can call it as it is unknown to the switch. And when it is unknown to the switch, what the switch is going to do? Switch will forward it out of all the interfaces. Got it?
Yeah.
That's what we call it as unknown unicast. Got it?
Got it, yes.
Yeah. So unicast, broadcast, and unknown unicast. Clear? Naresh, Deepak?
Yeah, Laksh. Clear.
Okay. So that I'll, if anyone has any question, please do ask now because I'll end the session. And tomorrow I'll explain the CLI of the switch or the router, whatever. We will get inside the CLI of the switch. We'll try to understand what are the different modes in CLI and how to use the CLI, etc. And we'll discuss even further.
And
Yeah,
this will be seen in that lab also. Unknown unicast
Sorry,
lab.
one by one. Yeah, sorry, Saugata. Yes, please ask your question.
Okay. So I'm asking this unknown unicast thing. Can we check in this lab also, like putting the switch and
Yeah, that's what we did, right? That's what we did first. And that is why I cleared the MAC address table. To show you that, I had to first clear the MAC address. If you do a show MAC address table, okay, it's empty. Okay, you can see the MAC address table is empty. So now let me try to.
okay, this became a broadcast, then it stored the MAC first. Okay,
Yeah,
and then
so
second
let
one.
me ping 10.0.0.3 PC1 to PC3. Okay, so PC1 will forward the data to switch. Okay, when switch will receive it, we can see switch will make an entry of the source MAC address, but the destination MAC address is not present inside the data. Inside the data, there is a destination MAC address, there is a source MAC address, but this destination MAC address of 433D is not present in the MAC address table of the switch.
Okay, the same thing we checked, right? Okay, got it.
Right. And
Got
when the MAC address is not present, it's going to broadcast. See here.
Got it.
This is unknown unicast. Okay, this is unknown unicast. For a broadcast, to check a broadcast, let me show you another example. Let me add a PC and give it an IP address 10.0.0.5. Okay, now, okay. Ping 10.0.0.1. Okay, now you can see there are two data that is created. There are two packets created. Yeah. So for a broadcast, you can see here, destination is FFFF. Destination MAC address is FFF. This is a broadcast packet. Why is this broadcast packet created? This is an ARP packet. We'll discuss ARP, ping, the working of ARP and ping probably later. Okay, but this is a broadcast packet. As I said, showed you FFFF. And on this switch, it's not necessary for the switch to have this FFFF present in the MAC address. It is understood by the switch that if I receive a MAC address of FFFF, I need to forward that data out of all the interfaces. So the switch will forward it. Okay, because this has not come up. That's why. Let this interface come up and then I can. Hmm. Okay. There was some problem. Give me a minute. Let me show you the broadcast once again. I'm waiting for the interface 0/6 to turn green on this switch.
I think so. We can click in this forward option.
Done. Yeah, over here, right? Yeah, thanks.
Yes.
I completely forgot. So now from PC number 6, let me try to ping again any other PC 10.0.0.4 for this example. Okay, and we can see that it will. This is an ICMP packet. This green one. We can see here. This is FFFF. This is a broadcast, and as I said, the broadcast does not have to be present in the MAC address table of the switch. It does not have to be present in the MAC address table of the switch. The switch already knows it's a default behavior of the switch, not just switch, any device which can understand MAC addresses. If it sees a destination MAC of FFFF, it is going to forward it out of all the interfaces. You can see here. This is what you call it as broadcast. It will forward it out of all the interfaces. This is a broadcast. So we just saw the unknown unicast and broadcast behaves almost the same. The only difference is that in a broadcast, the destination MAC is specifically mentioned as the broadcast MAC address. However, for an unknown unicast, there is a MAC address present, but the MAC address is not present in the MAC address table of this switch. And hence, it is called as an unknown unicast. All right. Okay, so with that, I'll close today's session. And tomorrow I'll explain the CLIs of the switch, and then we'll continue the topic for tomorrow.
Yeah, sure.
Sure,
Thanks.
Laksh. Thanks for the session, Laksh.
No problem.